So, okay. Mr. Benedict, well done. Welcome. Okay. Good evening, all. We just start. We've waited for a while. So, in the previous class, we have seen variable. We have seen how to assign a variable. We've seen how to run some simple program, even as simple as 1 plus 1. We've seen a bit more complex form of programming which encompasses our function. Today we'll start or begin from syntax, even though in the previous class we've seen that, but I think the number at which people are not in the class makes me want to just repeat it so that we catch up again. Okay, so we're talking about syntax in programming. It simply means the grammar of programming language. That's just it. So what does grammar stand here? Grammars are those rules that someone has to follow to either write or even speak a certain language, right? So here also in programming or Python, it has its own rules that you have to follow to create some variables, to create some functions, and then some other programs that you may want your computer to run it seamlessly for you. So here we want to look at the syntax of a function. So this very function, we want to see what happened or when is a function supposed to stop, or when are you supposed to know that you've finished writing your function or the operation that your function is supposed to run, and then the rest. Okay, from initial or the previous class we've talked about how to create or how to write a function. So in this very one here we can see that we define a function which is called example A. The first thing you have to do here is to write define, and this def is a function is a shorthand of what? Define, and the name of the function, and then follow by a colon. So when you place this column, you are telling your function that you want to write the operations that you want the function to do. So any other things that come down here, these are instructions that the function will do for you. And in this function, we define that the function should print example A is running. That's one. The second, we said it should print running value A. And the third, we said it should return A. And then here, okay, so here we've seen the beginning of a function. Where is supposed to be the end of the function? So we have two things that halt a function or stop a function or end a function. Here we have return 1. Once you write a return in a function, you are telling it to what? Stop from there, unless it's a condition of maybe if or else return this, else return that, which we'll see more on that when we get to nested functions. So but in this context here, this very return is the end of the function. So this is the function here that we've defined. So we figure that from running this very cell to see what the function entails. So you could see the first operation we told our function to do was to print example A is running, and this is it here. The second one here was to print returning value A, which is this. and then the third here is what? Return A, which is this. So we see that this has not been printed simply because return came here and then it hurt the function. That's to say, this guy here is wasting, so it has no use. Okay, you may say, okay, but we have this guy, what's the use? This is the name of the function if you look carefully. So this was what we called to print out this very operation from the function here. Okay, the second thing that hurt a function or stop a function is if you have no indentation. Maybe you want to write the second or third line or fourth line, then you do not indent. Maybe give a space just like I did here with no indent. That means once it get to this point here, which has indentation, the function will stop. Okay, so if we run this, we can see that it printed to this stage. This very one we have here is we just call the function to print the operations from the function. So that's what we see here in the grammar. As we go further, it will explain more. So now let's start function in conditional. Let's say there are some programs or some instruction you want to give to your computer. Maybe you want to clean some data. Maybe you want to do some analysis, maybe using machine learning or something. You may need some conditions. Maybe based on this condition, do this. Based on that condition, do this. If it's not this, don't do that. Like that. Okay. What do we use? We use mostly logical expressions. So let's say from this function here, we could see that we want to print the high score of a test. So we start by defining the function and we give the function this name, test high score. And then we have two arguments here. In contrary to before, we keep having just one argument. So a function can take more than one argument. As you can see here, we're having two arguments. So the first argument here is player score. And then the second argument is what? High score. Okay. And then here comes a condition. So this condition will return a Boolean expression. This will be either true or false. So if it's true, then it will what? It will print high score. Sorry, it will print high score, and then what? Update player score as the high score. Okay. What here is saying is that we have this condition. If player score is higher than the high score, you should what? Print high score. This is a string, so you should just print it there as the first line, and then print the player score, updating it as the high score. Else, if this is not bigger than this or greater than this, as to say if the player score is less than the high score, then you should what? Return just the high score. Okay, look at this argument we have here. So we have the player score to be what? 83, and the high score to be what? 98. So we can see that the player score is less than the high score. So we expect that it won't run this very programs we are having here, but return this directly. So you should what? Return 98. So let's run to see that. So we can see the output here, which is 98. So this is because the player score is actually less than the high score. So let's see the second example or expression. So we can see that here we have the player score to be greater than the what? High score. That's why it prints this very string for us, high score, and then updated the player score to be the high score. That's why we have 95 here. I hope that's clear. Okay, let's make it more clear using this very chart here. What we just illustrated here is just that we give a command to our computer telling it to check if player score is greater than high score. If yes, then print high score and update the high score as the player score, or update the high score as the player score. Okay, and then if it found that player score is actually not greater than the high score, then you should do what? Nothing, and just what? Return high score, which is what we just saw there. Okay, so let's see a more nested program here, which might give us more light, or it may give us, or will give us more lights. Let me see. Okay, here what are we trying to see? We are trying to use the if statement, which is what we used earlier too. So to illustrate a nested example, we have one which is nested on this, and this nested on this, and this. So here we define a function nested example, and then we give the name of the argument as x, and then we give a condition. If x is greater than 50, is less than 50, then you should check if that x is an even number. So in mathematics, the definition of an even number is that which can be divided by 2 without remainder, right? So it's divisible by 2 without remainder. So that's why we have here to be divided by what? So here we have a logic. Let's say we have a logic from mathematics, which is modulus. So in modulus, it divide a certain number and return its remainder. So let's say we have let's say 5, then the modulus, let's say 2. So what this has to return to us here is 1. Why? Because if you divide 5 by 2, you have 2 2's in 5, and then remainder 1. So modulus returns just what? The remainder for us. So here, if at all any integer or any figure that we give our function is less than 50, and then is divisible by 2 without any remainder, that's why we have equals to 0. If it's without a remainder, then you should what? Return branch A. Else, if this condition is satisfied, but the x value we gave is not an even number, then you should what? Return branch B. Okay, else here refers to from this function, from this operation till here. That's to say, if this guy here is not true, then it must not go further to check for this, but just return branch C. Okay, I hope that's clear. So let's run our function. Okay, before that, let's see the argument we want to see. Like here, we have 42, which is actually less than 50, and then 42 is divisible by what? By 2. That's to say we won't have any remainder if we divide it by 2. And then this implies that this very first line is supposed to return branch A. Okay, so the next line here, we're having 51, which is actually greater than 50 here. So definitely this operation here will not be executed, but this very one will be executed. So we see that the second print function will print out branch B. And then for branch C here, or let me say for this argument here, is actually less than 50, but it's not an even number. So definitely it should run to this extent. It should check that this is not valid, and then it should go and return branch B for us. So let's run that. Okay, you can see we are right. The first one here actually run branch A, the second one run branch C, and the third one run branch B. Okay, let's also see how or a clearer picture of what we just did there in programming aspect. So what we just did there was that we asked our computer to check if the arguments we gave is actually greater than 50. If yes, is actually less than 50. If yes is less than 50, then you should check if the argument is even number. If no, then you should just return branch C. So if yes, it's going to check that it's an even number. If yes is an even number, then it will return branch A. If no is not an even number, then it return branch B. Okay, that's what we saw in our that's the instruction we gave our computer earlier. So let's see this. Let me clear this so that we have more understanding. So there are some expressions in Python or even any programming that you may give a computer to an instructions or expressions to print out or to return, and then it may return some billion expressions for you. These very ones we are looking are amongst those that does that. So what kind of expression do give us such kind of expressions? That's billion expressions. Those are kind of the kind of expressions that actually return a billion expressions are those that are mainly for comparing sake. Let's say here you are comparing if 50 is actually greater than 10. Here we have double equation sign. In programming, having double equation sign is like here we're attesting or confirming that the left hand side is actually equal to the left hand side. Using just a single equation sign, it's like you are assigning a value to a variable in Python. So in that case, these very two equation here are here for what? Comparison. So here we have is 2 plus 2 equals to 4. That's how it's read in English, if I may say. And then the last one here we have is minus 3 greater than 2, which is not right. So we see that here should return true, here too should return true, and here should return false. So let's see that. So we can see that we got it. Here returns true simply because 50 is actually greater than 10, right? And here returns true simply because 2 plus 2 is actually equals to 4. And then here returns false simply because minus 3 is actually less than 2, not greater than 2. So that's for that. So if maybe you are conversant with common logic in mathematics, just as the truth tables, all this true and false, and then the rest, it will be more clearer. So let's look at it in this perspective, and I bet it will be more clearer here. So let's say we have two conditions that we want to see it satisfy, and then we have some operations that uses those conditions or compare those conditions. We have this operation, and in mathematics stand for multiplication. That's to say it will match the two expressions we're having here. And here and returns true only if both conditions are satisfied. If we have three conditions, only if those three conditions are actually satisfied, that's when it will return true. But if one of the conditions is not satisfied, it will definitely return false. But with all operation here, if we have two conditions which are actually satisfied, it will return true. And then if we have two conditions, but one is satisfied and the other is not, it will still return true. The only time these very operations return false is when we have both expressions. So let's have a admit. Okay, so now let's look at it more critically. So here we can see that this condition A and condition B are actually satisfied, since we are saying true here. That's why here returns true. And this very one also or returns true simply because one of the conditions is true, but actually it's true, right? Okay, so here we can see one of the condition is not satisfied. That's why we have false here, but this very condition is being satisfied. That's why we have true. But with AND operation, it will return false, simply because we have one condition that is not satisfied. But if you look at the OR operation here, true, it returns true simply because we have one condition that was satisfied. Okay, and here we have one condition not satisfied, the other condition satisfied. Here we return false, just like we see here, and then here we return true simply because we have one condition satisfied. Okay, so likewise here. Okay, if you look at here, both of the conditions or operations actually returns false, simply because in OR, if you have the two conditions or three conditions or all the conditions return false, true will return, the OR condition here will return false, and that's the only scenario where OR operation returns false for you. But for the AND operations, it always returns false whenever we have any condition of any number. Maybe we have just one condition of 100 number of conditions that were satisfied. So definitely it will return false for us. Okay, that's some hints that we may want to keep behind our mind, so as for us to keep progressing in data science. Okay, so let's look at more practical aspect of what we just illustrated here, so that you get it in more picture. So here we have the OR operations here, and we have some of the conditions to be satisfied completely, and some not satisfied. If you we see that here where we have and which both the conditions are satisfied, it returns true. Now, just this. While the remaining ones, since we have one of the conditions or even all the conditions that are not satisfied, and because we are dealing with and operations, they all return false. So let's see for the OR operation here. So for the OR operations, we have that this guy, the first one here, returns true simply because both of the conditions are satisfied, or should I even say either of the one of the conditions is satisfied, but actually all are satisfied. So here returns true because one condition was satisfied. Okay, simply because we are using what OR operation. If only one condition is being satisfied from multiple operations, which conditions which are not satisfied, it should definitely return true for us. So that's what we've seen here. And if all the conditions are not satisfied with all, it will definitely be false. Okay, so let's look at more complex form of that before we get in to even more complex ones. So here what we did here was creating two variables. So we create variable x and y. So we assign 5 to variable x and assign 3 to variable y. So here we come and then we compare to see using AND operation here. So here we have two conditions. We have x is x. Let me take it like a question to be more clearer. Is x greater than 4? Is it true or false? The computer will dictate that. But actually, it's actually greater than 4 simply because we know that we give x the value of 5. And then here we are dealing with an operation. And then we gave y value of 3, which is actually what? Greater than 2. So this very one here should return true for us. So let me comment this so that we see just that just okay, shifts. Okay, so if I should run this, okay, what's wrong? Still busy. Okay, we can see that here returns true simply because both of these conditions are being satisfied. Okay, so if I should remove this commenting, run it, it's return false simply because x is actually not greater than 7. So here is false, and then y is actually greater than 2, but we're using the AND operation. So if one of the operation there is false, definitely it will return false for us, and that's what we just see. So here, removing this, so we can see that this is true simply because we're using the OR operation here, because this guy here is true. Y, which is 3, is greater than what? 2. But here we have x, which is 5, is less than 7. But we ask, is this greater than 7, which is false. And then because we are using the OR operation, that's why it's pick only the positive aspect of the program and then give us back. Okay, I hope that's clear. So we could actually negate our Boolean expression and it will give us the opposite value of it, just like what we are saying here. We are saying not true, it will return the opposite, which is false. Not false, it will return the opposite, which is true. Okay, so in case you saw something like that, it's valid. So this very one too, I'll leave it for you to evaluate to see if it's correct. So we have some break, which I expect. Let me count the people online. It's me. Oh, just Benedict. So, Mr. Benedict, are you there?
Yeah, good evening, I'm here.
Oh, okay. So, how's your day? Okay. Okay. Are you following? Oh, so sorry. Understand. Okay, that's interesting. Oh, yes. Okay, that's good. That's very good. So here I have an exercise for you, and then it doesn't matter if you get it right or wrong. Like we still do it together, okay? So here the first one here is to define a function that returns if it is that function is greater than 10 but less than 20, or it is what less than minus 100. So that's the first task. Is that clear? Okay, and then this very one here is just to explain. You don't need to write. So once we come back from the break, you just explain what this percentage sign stands for in programming. Like I've already explained. If you were there when I explained that. Well, we still do it together. Okay. Yeah. That's nice. So we'll take let's say 15 minutes, 10 minutes break, and then we'll be back, and then we go on with iterations. Thank you very much. Okay.